Okay, so we are continuing 4.2. This is the third video, 4.2c. This has got to be painful. Sorry about that. This has taken so long, but I really want to make sure you get what's going on here. So 1/2 x minus 1/3 y equals 2. 1/4 x plus 2/3 y equals 6. All right, wonderful. We're doing this whole thing with fractions. Now, when you're doing this with fractions, there's a very difficult way of doing it, and there's a way that's a lot simpler. And I'm sure you're more interested in the simpler way, which means we get rid of the fractions, because I've never met anybody that likes fractions. So we can get rid of the fractions, then that will make our life so much easier. So before we do anything, we know that our numbers in front of our x's and the numbers in front of our y's are different. So we can't just add these and eliminate either the x or the y. Because remember, in order to eliminate, the signs have to be opposite and the numbers have to be the same in front of the x. So a -2 and a +2, or a -8 and a +8, or even a -1/2 and a +1/2. Then we wouldn't have to change the fractions to whole numbers. But since that's not the case, we're going to do that. So again, this is old stuff, but it's real easy to forget. In order to eliminate the fractions in this equation, we're going to look for the common denominator between 2 and 3. Common denominator between 2 and 3 is 6. So I'm going to multiply the entire equation by 6. So 6 times 1/2 is 6 over 2. 6 times 1/3 is 6 over 3. And 6 times 2 is 12. 6 over 2 is 3. 6 over 3 is 2. So this equation right here is this exact equation. We just eliminated the fractions. So we're going to hold on to that, because we're going to use it later on once we change this to just whole numbers. Okay, so let's do this bottom equation here. Change it. So what did I say? We need to find common denominator and multiply the entire thing by that common denominator between the 3 and the 4, which in this case is 12. So 12 over 4x plus 24 over 3y equals 72. 12 times 6. 12 over 4 is 3. 24 over 3 is 8. Okay, so there's our two equations. We can ignore this one now. We don't even care about that one. Now our equation looks like this. There's our first one without the fractions. Here's our second one without the fractions. Ah, life is good. Fractions are gone. Okay, but notice we cannot add these together, because remember, the signs have to be different, and in this case they are, and the numbers have to be the same, which they're not. Signs are different, they're not, but the numbers are the same. So all I have to do is I can take either one of these equations and just change to a negative, as long as I change the rest of them to their opposites. So I just changed that 3x to a -3x, and then I change that, and I change that, and I'm good to go. Now when I add those, my x's, -3x plus 3 is 0. Add these. Add these. -12 plus 72 is 60. Divide by 10, and my y then equals 6. Yay, no fractions. Everything is good. Now I'm going to take this, and I'm going to put it in either this equation or this one to find out what my x is. So let's put it in this one here just because it's right there. And my y is 6 equals 72. So 3x plus 48. Really helps to remember your multiplication tables, doesn't it? So 3x equals 24. 72 minus 48. Divide by 3, divide by 3. Those go away. 24 divided by 3 is 8. So your final answer, again, should look like this. X is 8, Y is 6, and you be done with example 6. All right, let's keep going. A couple more here. Example 7. I'm sorry, it's really hard to spend these nice summer days listening to me ramble, isn't it? All right, it's hard for me to spend my nice summer days rambling. All right, so that's 2, and then we've got 4x minus 2y equals 12. All right, so, gosh, let's see what we can do here. I would suggest us getting rid of the y's. Whenever you do not have a number in front of your y, or in front of the variable, whether it's the x or the y, it's always easier to get rid of those letters. We could get rid of this. We could multiply this top by -2, so that when we multiply these, we get -4. We add that, and our x's disappear. That's very doable. But if I multiply the top by a 2, what happens? We get 4x minus 2y equals 2. And then we have on the bottom, okay, do I want that? What happens when I add those two? I get -4. So that doesn't work, does it? So we're not going to multiply it by a +2. We're going to multiply it by a -2. And then we get -4x plus 2y, because a negative times a negative is a positive, equals -4. And then the bottom number we didn't do anything to. Now when we add, let's see what happens. -4x plus 4 is 0. +2y minus 2y, oh gosh, that's also 0. And that equals 8. What's 0 plus 0? Uh-oh. That does not work, does it? There is a problem here. And that problem is, whenever you get an answer like that, where you did all your math right, your variables disappear, and all you have are two numbers that are different, yet they're said to be equal, and you know that's not a true statement. What that means is these two equations do not cross each other. Because remember, the answer that you get is always where the two lines cross. Well, if the answer is untrue, then those two lines don't cross. So if you get an answer like that where the two lines don't cross, well, what are your other options? If they don't cross, or they have to either cross, remember, or parallel, or one on top of the other. Those are your your three options. So they don't cross at all. And when you get something where you did the math correctly and you get an untrue statement, that means the lines are parallel and they do not cross, which means you do not get an answer. Your answer ends up being the null set because they do not cross. Okay, so let's try another one. This is an example of two lines that are parallel. We have been doing two lines that cross. Now what we're going to do is I'm going to give you a problem where both the lines are on top of each other, so you can see what that looks like. So remember that when you're doing your homework, because if you get something screwy, like we did right here, they're parallel. If you get an untrue statement and the variables disappear, they're parallel. Very important to remember that. I'd write that in my notes. If you get an untrue statement and the variables disappear, the two lines are parallel, and the answer is the null set. There is no answer. All right, so let's choose a problem where the lines are on top of each other. And there are an infinite number of solutions because all the points that work are on top of each other. So there's an infinite number. Okay, there we are. Let's multiply this by a -2. And the reason I did that is I want that 4 to be a -8. So when I add a +8 to it, those go away, and I can find out what y equals. All right, so my top equation here is going to look like this. Negative 8x plus 6y equals negative 4. And let's just rewrite the bottom one. Okay, add those up, 0. Add those up, 0. Add those up, 0. Is 0 equals 0 a true statement? Yes, it is. So this is what makes it different than the last one. The last one we said 0 equals 8. That is not a true statement. This one, your variables all disappeared, but at least you ended up with a true statement. And that's the true statement you will always get. 0 equals 0. When you get 0 equals 0 for an answer, that means that the lines are on top of each other, and when you graph it, it's going to look like that. Well, it's going to look like, yeah, they're on top of each other. So the answer to this is there is an infinite number of solutions here. Okay? So you could write the cool little infinite symbol like that. I'm terrible at making an infinity symbol, but anyway, that's what it looks like. So you could give me that for an answer. Okay, that is it for lesson 4.2, and I'm not going to go over the problems in 4.2. I did examples of every stinking one that you're going to run into, so you should not really have any struggles with anything that's like, oh my gosh, we didn't go over anything like that. But I do want to at least look at number 38. And the reason for that is because you have some fractions and some not fractions. So let's just kind of wade our way through this one just a bit. Okay, so we have all these fractions here, but this one does not have a fraction. So what I would do, just if it helps, is to make it a fraction. Anytime you don't have a fraction, make it 1 over 1. Okay? So, in order to get rid of the fractions here, I'm going to multiply the whole thing by 3. So, let me put my parenthesis 3. So I get negative 6 thirds x minus 3y over 1 equals negative 12 thirds. So that gives me negative 2x minus 3y equals negative 4. So that got rid of all my fractions. I'm going to multiply this top one. Well, I have a 3 and a 2, so the common denominator here is going to be 6, isn't it? So I'm going to get 6 thirds x plus 6 halves y equals 12 thirds. So 2x plus 3y equals 4. So these are my two equations. So if I stack them, doesn't matter which one you put on top of which one because you're adding, right? And add those, and what happens? 0 plus 0 equals 0. And remember what I said, if you get 0 equals 0, the graph is two lines that are on top of each other, giving you a solution set of infinity. Okay, so that's what you do on one like, what one was that? 38. All right, so, gosh, a lot of material to remember. I guess that's why I took 3 videos. But again, ask me questions if you're having struggles, because a lot of students do have a struggle with this because there's a lot of new stuff going on here that you're expected to remember. So feel free to text me or email me any problems that you're having with this. So anyway, not many lessons in this chapter, so got done with 2 of them, and we only have 2 left. So you should be good to go after this lesson with just 2 sections left.